Now when it comes to these bridge protocol data unit types, we have two different types to deal with, and both are multicast to the well-known MAC address 0180C260s. And it might not have been well known to you before, but by golly, it is now. Now, I hate to even insult you by telling you what a topology change notification BPDU does. Hintity hint hint, the name is the recipe. We're going to see that in action later in a walkthrough, but right now and in the next couple of videos, we're going to concentrate on configuration BPDUs, and these are the BPDUs that are actually used in STP calculations. We're going to walk through a root bridge election here in just a moment. Once that root bridge is elected, only the root bridge actually originates those configuration BPDUs. The non-roots will receive a copy of that BPDU, which you'll see is very important. It'll also forward a copy of that BPDU, which is also important, but non-root bridges don't actually create a configuration BPDU. The root bridge also, by the way, is the switch that decides what the STP timers are going to be, and we will see that live in action after we have an election or two. Now, each one of our switches has a bridge ID priority value, which is much more commonly referred to simply as a bid. The bid is a combination of a 2-byte priority value and the switch's 6-byte MAC address. The priority value comes first in the bid. So for example, if a Cisco switch has a default priority of 32.768 and a MAC address of 112233445566, the resulting bid would be 32.768 : and then the MAC address after that. So this means that if the switch priority is left at the default on all of our switches, as it sometimes is, the MAC address is actually the deciding factor in which one of our switches is going to become the root. And the root bridge will be the switch with the lowest MAC address. Remember, on auction sites, the highest bid wins, but on Cisco switches, when it comes to the root bridge election, the lowest bid wins. Now, in some networks, I'm going to be blunt with you here, in some networks that's perfectly fine. In some smaller networks, you may not really even care which switch is the root. But as your networks get a little bit larger, we don't really just want to leave it up to chance. We don't want to say, well, you know, the root will just be the switch with the lowest MAC address. Because as we know, Cisco switches have an equal default priority value, but when it comes to the actual capability and location, you know, some switches are more equal than others. We also have to keep our Cisco 3-layer switching model in mind. You know, access, distribution, core. We're going to have a certain layer where we want to have our roots and a certain layer where we don't want to have our roots. It depends on the design of your network. There is no absolute one-size-fits-all answer, but the important thing is you know how to change the results of the root bridge election, and you also know how they got the default answer in the first place, that being the lowest MAC address. Let's go ahead and walk through an example first, and then we're going to do a live one. You know, switches are a lot like people. You know, when they first arrive, they announce to everyone around them loudly that they are the center of the universe and nothing else exists. Unlike some people, the switches are going to get over it. But seriously, folks, I'm not talking about anybody here. Configuration BPDUs are going to be exchanged between our switches until one switch is elected the root bridge. And using Cisco defaults, the switch with the lowest bid is going to win that role. We know that. Now we're going to walk through a root bridge election on a 3-switch network. And we're going to take a look at the election from each switch's point of view. Each switch is running that default priority 32.768, and the MAC address of each switch is the switch's number repeated 12 times. All 3 switches, through the magic of science or witchcraft, are coming online at the exact same time, so all 3 of them believe that they are the root bridge, and all 3 of them get very, very busy announcing that important fact. Now, since each switch believes it's the root bridge, all 6 ports in this example are going to go to the listening state. Each port has different STP states that it can go through. And that when they're in listening state, that allows them to hear BPDUs from other switches. We will review those states from your CCNA study in this particular section. But if the ports didn't go to listening state, you know, you'd have a lot of BPDUs flying around and nobody would be listening to anybody, and we don't want that. Now here's our network and the root bridge election from switch 1's perspective. Switch 1's got its own bid and it's getting bids via BPDUs from switches 2 and 3. Now switch 1 is getting those BPDUs, and it opens them up, looks at the bids, and says, hey, these are both higher than mine. I'm not getting any incoming BPDU, any incoming bid that is better than mine. So switch 1 will continue to believe that it's the root bridge, and it's going to continue to announce itself as such. Now, how do things look for switch 2? Well, switch 2's got a bid, and it believes it's the root when all 3 switches come online at the same time. And the BPDU that's coming in from switch 3 is not going to change its mind, because that BPDU has switch 3's bid. It is an inferior bid, and switch 2 says, hey man, I'm still the boss. But when the BPDU comes in from switch 1 and sees the bid inside there is superior to its own bid, switch 2 says, you know what, I'm not the root. And switch 2 will then do 2 things. It will stop originating configuration BPDUs that announce itself as the root, and instead it'll just start relaying those BPDUs that are sent by switch 1. Now how about our buddy switch 3? Well, switch 3 is about to get a massive inferiority complex because both incoming BPDUs contain superior bids. Now in that case, switch 3 recognizes the BPDU containing the best overall bid, and that's coming from switch 1. And just that quickly, switch 2 and switch 3 recognize switch 1 as the root bridge for now. That's what we call a cliffhanger. Now, so what's the result of that cliffhanger? Because root bridge elections don't really end. You know, you're not elected king for life here and that's just it. The root bridge elections, the BPDUs keep going out and keep going out. Now switch 1 is currently recognized as the root for this network, but if another switch comes along that advertises a superior bid, hey, that switch then becomes the root. Because what we have here is switch 4. Switch 4 has come on board and it is advertising a bid lower than that of switch 1. And this is why you can't just concentrate on the MAC address, because that priority value comes first. Switch 4's priority was changed to 24568, therefore the MAC addresses don't even matter. And when switch 1 sees that BPDU coming in, it says, hey, I'm no longer the root. You know, this other guy is, switch 4 is. And then switch 1 begins configuring the configuration BPDUs it receives from switch 4. Now these config BPDUs go out every 2 seconds. So first off, the detection of a new root switch, a new potential root, that goes pretty quickly, and then letting all the other switches know about the change, that goes quickly as well. Now, this example allows you to see the details of a root bridge election, but in your production network and even in your lab, you know, by the time you really cable everything up and sit down, the election's already taken place. So that's why I wanted to go through a walkthrough, and now we're going to go into a live lab with this. It's a good idea to know how to see the bids of your live switches as well as spot the winner of a root bridge election that's already taken place, and of course the loser of a root bridge election that's already taken place. For our first lab, we're going to use a 2-switch network, and the switches are trunking on their fast Ethernet 0/11 and 0/12 ports. This is going to be our first lab, and I'll see you on the very next video, and we'll start it up.